okay. And we start our why it's giving, hold on, okay, let me I may need to stop sharing first. It's just why it's get to the slides too that small. And I don't think we need to take a look of those. We already quite familiar with hold on, let me find the sharing screen. Okay, so if you recall last class we started, we not started, last class we already discussed more, I believe, about stack applications. That and last class we discussed about reversing, is it? Yes, reversing we discussed. We also discussed, hold on, let me find a different color. Last class we also learned the number base conversion. That okay, so that's regarding stack application. But today we will learn more. Okay, so the first we will learn is about postfix evaluation, and then we will learn how to convert infix to postfix conversion. Okay, but before we start to learn the algorithm, first let's understand the concept about infix and postfix. Okay, and this expression, we call it arithmetic expression. We all understand very well, etc. And we also use parentheses to make the preference. Preference of operators. So parentheses can override the operator preference. Is it? Okay, so that's regular. So this kind of arithmetic expression, we call it infix expression. So infix expression, it has parentheses. Okay, and the operator is between two numbers. And what is postfix? So if you take a look, the equivalent expression for the top one, this looks like this. So it has two numbers, and the follow two numbers, you have the operator. And after that, so basically this is going to be a number again, is it? And then you have another number, and then you have an operator. Okay, so this kind of expression, so the operator is after two numbers. This kind of expression, we call it a postfix expression. Okay, and as many compiler translate infix to postfix for faster evaluation. Okay, so this kind of expression, we call it a postfix. And in postfix expression, It doesn't have parentheses. Okay, no parentheses, just a number followed by an operator. Then how do we convert from this postfix, infix to postfix? We will learn the algorithm. We can use stack. Okay, and if you have the postfix, how are we going to evaluate the postfix? We can also use the stack. Okay, so that's what we will learn today. Okay, so we understand infix and postfix. Is it? So here, let's see more about the infix and postfix. Is it? Oh, we already saw that. Okay, then over here, let's see. So here we have infix expression, and then for the respective postfix is number and operator. Is it? So in this case, then you have, so this is one set. Then you will calculate the number. Then you have another set. Is it? So that's the respective, okay. And then for the next one, so here you have the first set calculated, then you can have the next set calculated regarding that. And then for this one, you have, this is the first set, then the next set, is it? And then you also have this set, and then you have the other set. Maybe we can pick a different color. Then, so this is a number, the dashed line, and the solid line is another number. Then you have of this as a set, two number and the operator. And for the next one, same thing. So we have this set, and then we have this set correspond, but no parentheses here. Is it? Okay, so we kind of get some ideas about infix and postfix expression. Okay, and then next, let's see. And for over here for postfix, we are going to discuss postfix evaluation. And for postfix, no parentheses. Is it? Then if we want to evaluate this, is it? We must need to know that this operator has a higher precedence. So has a higher precedence over plus. Is it? Over plus. So then we know, okay, we are going to first evaluate this. And after that, we are going to evaluate the next. Okay, because we strictly follow the operator precedence. Okay, not like the parentheses. Okay. Okay, then how are we going to evaluate the postfix expression? Okay, how are we going to evaluate? Let's see. Let's see, maybe I can use this example. Okay. So here we have this example. Okay. So we are going to discuss the postfix evaluation algorithm. Okay. For this algorithm, so normally you have a input. So this is some string formatting anyway, align, is it? Then we can start scanning from left. Okay, if this is a number, then over here you hold a stack. And the stack is a number stack. If it is a number, you put it to the stack. And then you continue your scan. Next is a number, you put it to the stack. Next one is a number, you put it to a stack. Next one is an operator. If it is an operator, you need to pop 2 numbers out. You get 2 out. And then you get 4 out. Okay, you get 4 out. So the first one get out, put it to the right. The second one get out, you put it to the, I messed up, okay. The first one you put it, the first one we put out, put it to the left. The second one put out, put it to the right. Here is the operator. Then we apply the operator. And then we evaluate this expression. So 2 minus 4, you get -4, is it? And then we needed to push this -2 back to the stack. Okay, so I'm going to push it back to the stack. So it's 3 and -2. Okay, so let me do the clearing. Okay. Let me also get this cleared. Okay, so I need to push this -2 back. That's it. So you calculate the result, you push it back, and then you continue scan. So if it's a number, you push it to the stack. If it is number, you push it to stack. Next is an operator. So if it is an operator, you push, you pop it out, so 6, and then pop 5 out, so 5, and apply the operator and calculate the result, and this result you need to push it back, so 30. Okay, 30. Now let me erase everything. Okay, then you can continue your scan. Is it? What next is a plus? Is it? Okay, the plus, then you need to pop 2 number out. Is it? So 30 plus -2. And we have 28. Is it? So then I need to push 28 back. 28 back. Okay, and then you continue scan its multiplications and operator. So if it's an operator, you need to pop them out. Is it? Okay, so 28 and then 3 times 3. So we have 84. Is it? And then you push this 84 back. And then you continue the scan. Now you reach the end of the line. So basically, then that means we need to stop. Is it? Okay, we stop, then we need to get to the remaining number out. So pop it out, 84. And then this 84 is our result. Okay, is a result. So that's how this algorithm works. So it uses a stack to hold all of the numbers, including the intermediate calculated result. Okay, calculated result. Okay, and I think over here I made a mistake here. Okay, so over here, we have 3, 4, 2. Is it? The first number pop out should be on the right. should be on the right. The second one pop out should be on the left. Okay, so just keep that in. The order doesn't matter, is it? Because this should be 2 versus -2. Okay, so I made that mistake. So the first number out is on the operator's right. The second number out is on the left. Okay, on the left. Because for plus and multiplication, it doesn't matter. But for minus, for subtraction and division, that does matter. Okay, so that's the algorithm. Okay, and then for the algorithm in the class, in our class slides, we also have this algorithm listed out, etc. So let's see this algorithm. So we scan token, is it from left? If it is number, then we push it to the stack, is it? If it is operator, then we pop 2 number out of stack and apply operator, then push the result back to stack. So we already saw that, is it? And after all tokens have been scanned, then should be only 1 number at the stack, on the stack, then pop it and it is a value. Okay. And with this algorithm, we can also find illegal postfix expression, is it? Because if whenever you have an operator, if there are not 2 numbers to be able to pop, then that means something is wrong, is it? And also at the very end, when you finish a scan, there should be just 1 number. If you have more than 1 number in the stack, that means something is wrong. If you don't have any number to be popped, that also means something is wrong, is it? So this algorithm can also help us to detect the wrong postfix expression. Okay. Okay, so we have this, yeah, so my result is off because the order doesn't matter. Okay, so be careful. Okay, so we can take a look more exercise, is it? So how about let's take a look at this one, the second one, is it? So we need a stack, a number stack, is it? So it's a number, we push it to stack. It's a number, we push it to stack. It's an operator, we need to pop 2 numbers out. So we pop 7 out, then we pop 5 out, and we apply the operator, so it's 12. And then we push it back. Okay, and then we can continue 2, is it? And next, it's multiplication. If it's multiplication, we need to pop 2 numbers out and apply the operator, and then we get the result back. It's 24. And we can continue scan. It's 3. Push it to the stack. Next is plus. Okay, then we need to pop 2 numbers out. Pop the top 2 numbers out, and we calculate it's 27, is it? And we push it to the stack. Okay, now we reach the end of the scanning, is it? And we need to pop this number out, 27. And the stack is empty, is it? So this is a correct postfix expression, is it? And the result then is what? It's 27. Okay, so you can see it's pretty straightforward, is it, with this algorithm? Okay. And for the other 2 after class, you can exercise. Okay, you can take a practice. Okay, so that's a postfix evaluation. Okay. And what next one is, how are we going to convert infix to postfix? Okay, if we want to convert infix to without using a stack, then we need to order the operator by precedence. Then we can convert each one based on that order. Okay, then in this expression, then we know this is, we needed to do the very first step, is it? Then this is going to be second. After that, we do this parenthesis, so this is third. After that, we do this is the last, is it? So how you are going to convert, okay. So you know, this is first, so you convert it, is it? And this is the second, then you convert it to something like this, second, is it? And after that, okay, the third one, okay, because this already, part already fixed, is it? So that's why you just add 2 here and add the minus sign next, is it? After you finish this, then you move on to the next number, because each time you have 2 numbers, is it? And then the operator after it. Okay, so now you can convert. But if you ask a machine to do this, that's going to be hard, okay? So for machine, then if we want to do that, then we need some algorithm. Okay, we need some algorithm. So we can go back using, let's see if we have the example. Okay, yes, here we have this example. I can also use the other example. Okay, it's 3 plus 5, etc. And something. Okay, so over here it also involves scanning. Okay, let me do this. Maybe I can minimize a little bit, because we all be able to see the expressions, that it will be easy for me to do the tracking. Okay, so over here, then this time, what we are going to have, we're also going to use a stack. But this stack is going to be an operator stack, not a number stack. Okay, and on this side, I'm going to put the postfix expression. Okay, postfix. So let's see. Still the same. We are going to do token scanning. Scanning token. So the first one is left parenthesis. If it is left parenthesis, I need to put it to the stack. Next one, left parenthesis, I put it to the stack. Next one, number. If it's number, I put it to postfix. Next one is an operator. If it's an operator, at this point, because the top is left parenthesis, so you just push it to the stack. The next one is a number. If it is a number, I'm going to add it to postfix. And here means a space, okay? Because otherwise it's going to be recognized as 35. So you need to have some delimiter. I use space for delimiter. Okay, delimiter. Okay, and then what next is right parenthesis. If it's right parenthesis, that means you need to do some calculation, is it? So what over here, then you need to do is you need to pop the operator out of the stack and apply it to the postfix until you reach one of the left parentheses. Okay, so over here, if, oh, I forgot to write. Okay, so let's start beginning. If it's left parenthesis, so if token is left parenthesis, okay, so how about let me just write like this, then push to stack. Okay, and if token is number, then we add to postfix. Is it? And if it is an operator, is operator. But here, and top of stack is left parenthesis, is it? Then you just push operator to stack. That's what we just do, is it? And then if it's number, we add it to post. Then we have right parenthesis. So if token is right parenthesis, what do we need to do? We need to pop operator of stack, add to postfix, add to post. You need to keep doing. Okay, if there are more operator, you need to keep doing. Okay, you need to keep doing. Keep doing until what? Until top of stack is a left parenthesis. Then you pop this left parenthesis out. Okay, then you stop popping. Stop popping. Then you continue. Okay, continue. The next is a operator. If it's an operator, what do we do? And the top is also a left parenthesis, is it? Then we need to push it to the stack. Okay, next one, 4 is a number. If it's a number, you need to add it to postfix. Next one is a minus sign. Is it a subtractor operator? Subtraction operator, the top of the stack is also an operator, not left parenthesis. So this case a little bit complicated. Okay. So I'm going to first erase all this. I'm not going to have enough space to write. So now I'm getting to the minus, okay, side. Okay, then, so now the token is this minus sign, and the top of the stack is also an operator, is it? So if token is an operator, and your top of the stack is also an operator, and it doesn't have, and the top of the stack, okay, is also operator, then what we need to do is we need to compare the precedence of these two operators. Okay, definitely this doesn't have a higher precedence than the top of the stack, is it? So then over here it involves a loop. Okay, while, okay, while the token doesn't have higher precedence, then the top of the stack the top of stack. What you need to do is you need to pop it out and apply it to postfix. Okay, so if it doesn't, then pop out and apply to postfix expression. You need to keep doing, okay? Over here, if it has more, you need to keep doing. If it doesn't have higher precedence, because next, if it's a plus, you still need to pop it out, okay? If it's division, you pop it out, okay? Because this token doesn't have higher precedence, then you need to keep. Until what? Until, but now, after we pop that multiplication out, then we have left parenthesis, then you stop. Is it because it's not an operator? Okay. Then we stop. Okay. Then you continue scan. So the next one is 2. So if it's a number, then you apply it to postfix. And the next one is a right parenthesis. If it's a right parenthesis, what do? You pop everything out until you see the left parenthesis. Is it? Okay, we pop everything until we see this left parenthesis. Okay, and then next is a plus sign. So it's addition operation, then the stack is empty. So you just push it to the stack. Next one is a number. If it's a number, you add it to postfix. And now you reach the end of the stop, end of the expression, is it? After you reach end of the end, you just get all operator out and apply it to postfix. If you have more, you just keep popping and add them here, because over here we don't have anything. So that's the end of the postfix expression, is it? So let's compare this 3, 5, then plus, then 4, then times, then 2. Oh, I forgot to, I also need to push this token back. Okay, so after we pop that multiplication out and the no operator, then I need to push this back. Okay, push the minus sign back. And then we have the 6, and then we have the plus. Is it? So it's the same as what we did here. Okay, so this is the algorithm. Okay, and then next, let's take a look. So we just use an example to explain the algorithm. Next, let's take a look. So the algorithm. So it's a scan token. If it's left, we push to the stack. If it's right, you pop. Is it? You need to pop from the stack, apply the operator, and add to postfix until the left is reached. Is it? You pop it out, then you stop. And if it's number, you just add to postfix. Okay. And if token is the operator, then it's a little bit of more complicated. Is it? You need to compare with the top. So while stack is not empty and the token does not have higher precedence than top of stack, you need to pop and add to postfix. But after you finish this loop, then you need to push the token back to stack. Okay, push the token back to, I forgot that step, okay. And after all tokens have been processed, you just empty your stack and add all the tokens to the postfix. Okay, so that's this algorithm. We kind of have some idea, is it? And we can take a look more about this example. And let's see. Okay, and we can try more with this algorithm. So we need a operator stack. And here we have the postfix expression, is it? So we are going to do scanning. So it's left, and so you push it to stack. It's a number, you add it to postfix. It's an operator, but the top of the stack is left parenthesis. So there is no precedence. So you just push it to stack. Next one, left parenthesis, you just add it to postfix. Next one, number, I add it to postfix. Next one is a plus sign, and you need to compare with the top. There is no comparison, you just push it to the stack. Next one is a number, you need to add it to postfix. Next one is right parenthesis. If it's right parenthesis, you need to pop it out, add it to postfix, keep popping until you see the left parenthesis. You just pop it out, and that's it. And then keep scanning, it's right parenthesis, then you need to pop. I need to pop it out and add it to postfix. And until you reach the left parenthesis, you pop it out and then start scanning again. It's a minus sign, you add it to postfix. Because add it to the stack because stack is empty. And the next is a number, so you add it to postfix, is it? And now you reach the end of the stack. So you're going to pop it out and add it to postfix. So now this is your postfix expression, okay? So this is how you convert from infix to postfix. Okay, and there are more examples, okay, and we can try one more. How about let's try this one, okay. So here is a number, so we add it to postfix. An operator, we add it to stack. A number, we add it to postfix. And then we have an operator. This is token. So if token is an operator, top of stack is not left parenthesis, not empty. So we need to compare. If it doesn't have higher precedence, you need to pop it out and add it to postfix. And now it's empty, nothing to pop. So you need to add this to the stack, okay. And then next it's a number, okay, I add it to postfix. And next is an operator. And then you need to compare with the top of the stack because it has higher precedence. So you just directly push it to the stack, okay. And next is left parenthesis. You just add it to the postfix. Next is 7, so add it to the postfix. Next one is subtraction. So you compare with the top of stack. It's left parenthesis, so you just push it to the stack. Next one is a number. We add it to postfix. Next, right parenthesis, you need to pop the operator out and add it to postfix and continue pop until you reach the left parenthesis, you pop it out. And now we reach the end of the expression. When you reach the end of stack expression, you need to keep popping everything out and add it to postfix. Now this is the respective postfix expression, okay. So that's how we apply this algorithm, okay. So this is infix to postfix expression, okay. So we understand the algorithm. And after we know infix to postfix expression, then basically we can put it together. Is it if you have an infix, then you can do infix to postfix conversion. and you have a postfix expression. And with postfix expression, you can apply evaluation, postfix evaluation, then you will find the result. Is it? So with both of this infix to postfix, then we evaluate postfix. Then basically you can write a calculator application. And if you recall previous, we also learned the Java FX. So you can, basically you can write, after we learn this, you can write a Java FX calculator application, okay? And you can try, okay? So then you can have a text field to take in the infix expression that you take in, and then you do the scan and the infix to postfix algorithm you apply, you get the postfix expression. After you get postfix, you can apply the postfix expression evaluation algorithm, and you can do the calculation result. Is it? Then you can display it. And with your calculator, is it okay? So here is your infix, and here are like 1, 2, 3, 4, 5 something, and then here you have the calculator, is it? Then it can also show the result, is it? Yeah, so you can try. This is a good exercise, okay? So this is about infix to postfix conversion and evaluation. We already know how to do it, okay? And the last concept in this chapter is about runtime stack. Okay, runtime stack. So if you recall previously, we said we have a runtime stack, we have a heap memory. Is it? So here is the stack. Is it? And if you recall any application, it consists of multiple methods. And in other programming language, we also call it a function. Okay, function. So in Java, we call it method. It's a method, including main method. The main method. Okay. So basically, in operating system, okay, it has a runtime stack to store all the information. So it says whenever a function begins the execution, is it? Then basically there is something called an activation record is created. Okay, and that activation record is going to be used to store the method parameters called state, is it? And local variable and the temporary storage of those information. Okay, it's going to store because otherwise there's no way to put it back, is it? So this is a runtime stack called. And just think about in your program, is it? You call, so method A call method B, then method B also call method C, is it? But when method A call method B, it's not finished its execution, it's just halfway somewhere within the function, is it? So here is supposed to call method A, is it? So you have statement, and over here you call B, is it? And then you have more statement. So when you call B, basically it's jump into B execution. So when B finish, how can it know it's go back to continue its execution? Is it? So you need something to remember. That's what we use a stack. Is it? We use stack, then you can put A and then B. And the top one on the stack is the most current one. Most current, okay, B is execution. Is it? So that when B finish, then you remove it from stack, then you can go back to A. Is it? Because that activation record keep track of where you jump into another function, then you need to resume back your state. Is it? So that's why we said, okay, LIFO, it displays the LIFO behavior. Is it? And for LIFO behavior, then the best data structure to store information is stack. And that kind of stack, we call it a runtime stack. Okay, it's during the execution. Okay. So what happens is that when a method is get called, it's basically it's push a copy of its activation record onto the runtime stack, then copy all of its arguments into the parameter space, and transfer control to the address of the function's body. Okay, and always the top activation record is the function that's current being executed. Okay, being executed. When a function terminates, that its activation record will be out of the runtime stack. Then the new top activation record is going to restore the environment of the interrupted method, is it? And resume the execution of the interrupted function. Okay, so that's how operating system handles, and how can it also keep track of all of the states. Okay. And over here it shows, is it? So if you have main call F2, then F2 call F1, F3 call F2, is it? Then in this case, how are you going to keep track? Is it? If we have the runtime stack, then we can keep track. Is it? So function, if we take a close look, we will find basically method call. Method call involves you push the activation record to stack. Is it? And after you complete, then you need to pop it out of stack. So basically, all of this are function call overhead. Because you needed to put it to some other temporary storage. Is it? So that's a function call overhead. Okay, if you don't write as a function, if you just statement by statement, is it? Then it won't have those overhead. It's just execution, is it? So that's why a lot of times we say function call has some overhead. Okay, so that's how function call overhead also come from. Okay, so basically that